I'm going to begin with what I'm calling a plain language discussion of our topic, which in this case is artificial neural networks. For those of you that are familiar with the website Reddit, this is sort of like the ELI5. We're going to explain the topic like year 5, and then after this, we'll return to a more normal or more advanced discussion of the topic. So a neural network is a connection of simple units called neurons, and sometimes we'll refer to them as nodes. Each node or each neuron represents the simplified behavior of a real neuron in our brain. Now, I should preface this by saying it's very simplified. Each neuron or node performs 4 tasks, more or less. It accepts scalar input values from other neurons or from the environment potentially. It multiplies each scalar input by a coefficient that we refer to as its synapse weight. It sums those scaled values together to yield one that we refer to as h. We also call that the weighted sum. And then it applies some function, we call it an activation function, to that weighted sum. In short, each neuron accepts several values and generates one value output. And so here we have a very basic schematic of a neuron. I'm going to come back to this later. But in short, we can see we have 3 inputs coming in. We have 3 coefficients. They are multiplied, scaling those inputs. We then sum those together, we apply an activation function, and we generate an output. So keep this in mind, we're going to come back to this figure. There are many different activation functions that may be used in artificial intelligence. One common activation function is the unit step, and for that, if the weighted sum, which we called h previously, is greater than some threshold, it generates a 1. If that weighted sum is less than some threshold, it generates a 0. So it looks a lot like this. The activation function, whether it's unit step or something else, defines how a neural network processes inputs and generates outputs. The most basic neural network structure is feed-forward, where inputs are observed, pass through one or more layers of neurons, and then one or more outputs are generated. Ideally, that output or those outputs match the behavior of some complex system that we're trying to approximate. So one example could be recognizing someone's face. Before training, however, this will not be the case. It would be highly unlikely for a neural network before being trained just randomly by chance to match the behavior of some complex system. We use machine learning to teach our neural network how to perform some desired task. This requires us to give the neural network training data. That includes inputs along with known ideal outputs. And then we vary the synapse weights, remember those are the coefficients of the inputs, until it acts in the desired way, or the way that we want it to. Just like learning to shoot a free throw, we can keep changing our method until we consistently achieve our goal, which in that case would be making a basket. Let's say our neural network generates a value that's too high as compared to the ideal, we can reduce some of the synapse weights. If the neural network generates a value that's too small, too low, as compared to the ideal value, we can increase some of the synapse weights. Machine learning is inherently an iterative process. There are many interesting artificial neural network types or characteristics that artificial neural networks can have. A deep learning neural network